I have been using Go professionally for some months, I think about 8 years now, and I've been giving training courses in Go for maybe 4 or 5 years. I've given it to organisations you may have heard of. I've given it to organisations that I wish I hadn't heard of. So I think I have received a modicum of proficiency in the language, but we will find out how good that proficiency is over the next sort of 90 minutes. Now I have to start with an apology. You'll notice that this year's T-shirt is somewhat Go themed. That is the Go mascot. I may or may not have had something to do with this. The plan was that either the artist who created the T-shirt, who is sat over there in the corner, was going to do my slides as well. And I was going to have them all in a similar style, and it was going to be great, but apparently she needs more than 3 days' notice. So sorry about that. As recompense, I encourage you to go check out her Instagram and look at her art. It's fantastic. I'm now going to rub salt into the wound because I turned to one of the tools that she's terrified is going to take her job as an artist, and asked Midjourney to draw me GoLang generics. This is just the prompt I gave it, GoLang generics, and well, yeah. But if we consider when I asked it generics, that was the only prompt I gave it, generics, it gave me this. So the terrifying gopher kind of makes more sense now because it's taken the gopher and it's taken the terrifying generics thing, although I now have more questions. One of the other variants it gave me for generics is this, which is probably going to be a good representation of the code we produced today, just as fair warning. To make things even worse, and to add even more insult into the wound, it is Ida's birthday today, and her gift from me was to be dragged to a tech conference. Happy birthday, your job is safe, because I asked it to do a picture of the GoLang mascot presenting a huge birthday cake, and this, I'm not sure what you call that, came out, but happy birthday. It's terrifying. This was the least creepy of the options. So we're going to forgo the images because it turns out that Midjourney is just not really up to speed for doing this. And we're going to jump into the IDE. I'm going to spend most of the session in the IDE. And this is a good time to check that everything's been recorded. I think it is because there are no slides, just code. I do like this. This is the prompt. There are no slides, just code. Midjourney has given me an Nesail Caligdavi, which I think is Welsh. It's also interpreted slides literally. So here we have some slides. The similarity between these sort of, I don't know whether it sort of has context and keeps a similar theme for a given user. Which may explain some of the later messages I've got coming out because I've been doing a lot of very single-themed stuff. But yes, this kind of post-apocalyptic industrial kind of vibe may give you an idea of what's coming in terms of what my code looks like. Incidentally, this last picture that it produced, I would like you to ignore this and pretend I look like this. This looks much better. So yes, thoughtful and like I actually have a vague clue. So I'm gonna sit down and give the cameraman a break, so he doesn't have to follow me around. I'm gonna take these off. We're going to be in a problem now where I can't really see my screen or you, because I don't want to keep changing glasses. So I'm just going to squint at everything. Actually, before we jump into the IDE, I'm going to jump into the terminal. A couple of interesting things. So when I do training courses, there's a bunch of stuff that people tend to ask, especially if they're new to Go or new to programming. Actually, before we even go to that, let's have a show of hands. Who has programmed in Go before? Hands up if you have. 2 at the back, excellent. Who has heard of Go? Everyone, you've heard of Go, you draw the T-shirt. So everyone's heard of it. Who doesn't consider themselves to be a programmer? Excellent. I use Macs. I love Macs. Other operating systems exist, but I deploy on Linux because I'm not a sadist. And there's an interesting difference, which everyone knows about on Windows. Windows has a case-insensitive file system, not really a problem. Macs look Unix-like. In fact, they are more related to Unix, capital Unix, than Linux is. But by default, their file system is case-insensitive. Now, you'd think you could just change the file system to be case-sensitive because there is that option and just run your whole machine like that, but it turns out that developers are lazy. And there is no actual guarantee that any given program is going to work if you have a case-sensitive file system, because they may be relying on the fact that it is case-insensitive, as it is by default. I discovered this the hard way when I deployed something out to production on my Linux servers, which of course is case-sensitive, and things were not being found, and I'm looking at it going, but... So, all of my code lives on its own drive. Small partition on my drive. This has been formatted with the case-sensitive file system. So that entire class of problem goes away for me. The rest of the drive is available for everything else. And if we have a look, I should do that with, so -H for human. It was a 100 gig partition, 93 gig after you've fiddled around with it, and I have used very little of it, and all of my software is on here, so you know you can have much smaller partitions. Back in the olden days, some 5 or 6 years ago, Go insisted that everything lived under a single root directory, which was your Go source directory, and that was great if you only ever did Go, but if you did other programming languages and had other things that you needed to accommodate, that could be really quite painful. So thankfully these days you can put your Go modules wherever you want, but I still actually quite like the paradigm that was enforced. So I do still keep everything under a single source directory. And I think this also comes from the fact that I used to be a Java developer, and you have that source directory with that as well. And then I tend to follow the Go package or module structure, insofar as the next directory underneath is the source code repository that you're putting things from. I used to use GitHub. I tend to use Bitbucket these days for reasons, which will be explained on Saturday, actually. So everything under Bitbucket, different things that I work on and have pulled down. So for this particular one, I'm just going to use my personal one. And then all my projects underneath there. So it's kind of obvious where stuff is, and it ties up with where it is in the source code control, and ties up with the module names. So that's all good. That said, I think, yes, because I'm using my training course stuff, which lives under Bitbucket, GitHub. Dom's first law, typing ability is inversely proportional to the number of people watching. There we go, and I've created an example directory, and in there I've just popped a couple of very basic files for the moment, just to kick us off. What I actually do with my workflow is I have a package that will generate a template project. So it's going to have a README, a license, a basic make file, because I tend to use make. We'll look into that later. Into settings and all of that stuff. I'm in the middle of rewriting that, and I have no idea if it actually works at the moment. So we're going to be copying stuff manually rather than viewing live failures. Now, for the moment, let's have a look at my Go mod file. Go mod file, it defines your Go module. It's basically, this is a module in Go. This is what it's called, the first line module. And idiomatically, they are called where you find it in source code control. And when Go goes off to find packages, it'll go look at that particular source code control repository and try and pull it down. And then there's another line in here that just says I'm using Go 119. It's not the latest version of Go, but the last training course I did, there was a problem with the debugger and Go 120 with the particular IDE I use. I don't want to be debugging the debugger live in a session. So we'll stick with 119. There's nothing major that's been put into 120, and it's 118 where the big changes came in. So we've got that. This file is generally auto-generated, so as you start importing modules and what have you, it'll create that. And the way you create these things is just go mod init and then the name of the module. So you would do go mod init. That creates your file. If you have imported some other modules, you'll get a go sum. I think mine's going to be empty, yes, because I've got nothing in there at the moment. Your go mod and your go sub go into source code control. And then I've got a main.go, just because, why not? And we'll start having a look at what's going on with that particular thing. Now, I tend to put my main entry point in the root of my projects. If it's a library, then I will sometimes have stuff in the root. Sometimes it's all under sub-packages, because it just depends on the semantics, and we'll look at the semantics in a bit. But you can put your entry point anywhere, and in fact, if you've got a project that has multiple binaries that drop out, for example, you will want your entry points to be in different directories. So there are different layouts, and this is just one way of doing it. I'm not saying it is the right way unless you work for me. But yeah, your mileage may vary. I use GoLang. I am not sponsored by JetBrains, but I do love their IDEs. And it's an expense I don't mind paying. There is a free version of GoLang which you can use. I don't know if there's a community version, but it's definitely a free trial for a month. And then there is a modest yearly subscription. In fact, it's cheap enough that I buy all products subscription. So this is a Go program, doesn't do much at the moment. We're in package main. Package main is a special package. It says I'm the entry point to the program. And we've got a func main, and func main is the entry point. It's nil-adic. It takes no arguments. It returns nothing. And we can do stuff. So you know your standard thing to do. Let's do println. We've got the hello world with correct capitalization and commas and everything as I believe it. Now, Go is very, very opinionated about everything. For example, your braces have to go on the same line with the opening brace. This is a compiler error, as it should be. And the tabs versus spaces argument has been solved. My IDE does it for me. I honestly can't remember if I use tabs or spaces. But my IDE is clever enough to know what language I'm in, so if it's Go files or make files, it will put tabs in. And if it's other things, it'll keep the spaces in. And if I use tabs or spaces, it will convert for me. There should be no argument. There are other things that we will discover that the Go mandates as we go along. And a lot of these are compile errors. It's not a kind of a suggestion. It is you're not running this if you don't do it right. And part of the reason for doing that was to get rid of an entire class of non-problem. The amount of cognitive load that I've had with teams arguing about, should we do it this way, should we do it this way? No, the compiler says you must do it this way. And you get used to it pretty quickly. When I first started programming, braces went like that because only an idiot would do it any other way. Then I started using TCL, which insisted that braces go like that, and then I moved on to Java, and now you do it like this because only an idiot would do it any other way. I'm pretty sure if I used a language that indented the braces as well as had them on the next line, I would get used to that and think that only an idiot would do it any other way. So the only thing I don't accept is the braces hard right, which some people have done with, I think it's Java, to make it look more functional. Another thing you'll notice about my setup, possibly, if you squint, there is a line here. This is the 80-character column. There is actually another line slightly further off, but because of resolutions and stuff, at the 120-character column. Unix and Unix-like operating systems are built on tools that were made in the 1960s and 1970s when 80 columns was a thing. Less so these days, but there are some tools that don't work as you might expect or can do odd things if you've got long lines. It's not a hard and fast rule. I will allow it to go a couple of characters over, which is why I've got the 120. 120 is a hard and fast, which comes from line printers. I mean, these are arbitrary figures. The other thing that people argue is, we can have long lines because we've got big monitors and they're widescreen. And, well, I sit in front of a 27-inch 5K monitor at home, and if I've got two code panes open that I want to compare stuff side by side and my project navigation window open, I can just about see the 120 character line marking. I'm not paying for a bigger monitor to deal with the fact that you can't format your code nicely. So we'll see me dealing with line lengths in various ways, and there's lots of different things you can do to cater for this. So we've got our Hello World program, and there's a lovely little arrow here that we can go off and build and run. And so all this is doing is, actually I don't know what it's doing in the background. What I would do if it's doing for the command line is just go run and main.go, and that'll compile it somewhere. I think this is it compiling it somewhere, temporary, and chucking out the output of that binary. Now that is a statically compiled binary. If I was to do a go make, it would produce me a binary that I could give to you, and on most operating systems you would be able to run that if it was the same operating system that I compiled it on. Macs, it's slightly different because of the security system, so it will ask you, this has been written by someone who isn't verified, are you sure you want to run it? And there's a few things you need to do to get it to run. You can make it so it's a verified binary, but you need to pay Apple, and there's hoops. And I've never needed to jump through those hoops, so I'm not entirely sure what they are. But suffice to say, you can compile it to a binary that will run pretty much anywhere. And that becomes useful, as we will see later. So yeah, Go was designed to be a language that's easy to grok, easy to hold the entire language in your head. And the idea being that the Google goes through a lot of interns. You've got a lot of interns coming in, and what they do is considered to be vaguely complex. So you want people to get up to speed quite quickly. So why not use a language that assists that? So Go is a simple language that prefers maintainability over expressiveness. So it works on the premise that typing is not too hard. So you may have to write a little bit more code in Go, but it tends to be more understandable. And it's my conjecture that I want to be able to edit the code and fix the code at 3 a.m. in the morning when I've got a trailer shouting at me, and that has happened to me in the past. And they are very expressive when things are not working. Very expressive. So Go is a simple language. We shall see. Let's take our program slightly further. I'm going to refer to a crib sheet here. We're going to do FizzBuzz. Everyone know what FizzBuzz is? Anyone not know what FizzBuzz is? No one? Okay, cool. So we're going to output FizzBuzz. So what we're going to do now. Interesting thing about Go, there are no brackets with your control thing. So where you might expect to see brackets in other languages, or brackets, angle brackets, colons, and various other stuff. I don't know, it's up to whatever language you use. There aren't any brackets in Go. Also, this is a syntactic sugar for var I, and also because the compiler is reasonably smart, it can infer that this is an int. Probably important to note that ints are an alias on a 32-bit platform. They're an int32. On a 64-bit platform, they're an int64. If you absolutely positively must have an int64, and you may run on a 32-bit program, specify that it's an int64. We're going to do this so that it is, let's do it to 100. Another thing to point out, I'm using ligatures with my font. There are two schools of thought about this. There are those who love it and those who think it's a thing that should not exist. I am in the former camp, but this is 2 characters. This is less than and an equals, and the font just squishes it together. If people object to it immensely, I can turn that off. And we're going to do I++. So there's a very standard for loop in Go, and we're going to say if I modulo 15 is equal to 1, we're going to do ran.seed, and we're going to do int64, and we're going to do 176.064, and I need to use the deprecated version of rand for reasons, and then we're going to do format.println, And then that's going to be a slice of string, format.sprintf, %d. It uses C like formatting strings when you're doing output. Fizz, and then buzz, and then fizz buzz. Actually, what we can probably do there is do it that way. Dun, 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 dun. That needs to be the correct type of braces. And then rand dot int 63 modulo 4. And if you were in Transtalk, you would know that this is possibly not the best way of using Rand, but she's a mathematician, so what does she know? Other things that Go insists on, if you've got something like this, you've got to have a dangling comma. I hated that when I first started doing Go. I've come to like it. So yeah, we're just going to do a format.println there just to give us a new line, and then hopefully, fingers crossed, if I run this, we're already doing a format.println. We don't need that. Live debugging. Yeah, let's run that. There we go. I think that is a correct implementation of FizzBuzz, and as you can see, that is a very simple, easy to understand piece of code. Obviously, I'm being facetious here. This relies on the fact that this particular random seed produces a series of 15 values, which give me the correct index in this slice, such that it will output the number or the fizzes and the buzzes at the correct time. The point here being that although the language is a simple language and is easy to understand, it is entirely possible to write absolutely hideous code in fact, in any language. So just because it's simple doesn't mean that you can't tie yourself up into horrible, horrible knots. And I have done so, and hopefully we will do so today, because we're going to be looking at some of the new fun stuff they've put in. Done that. Error handling, this is one of the massive complaints about Go. You may have some other languages. The compiler's going to hate this. Let's do sort of Java-ish type thing. You may have something where it throws exception, then we go try, and then we do loads and loads of stuff, and then our error handling. Well, our error handling may not even be putting a try in there, but we may actually catch, E exception, and then we may do something sensible with our error handling, like throw E. So people complain about Go's error handling and the fact that it makes you handle errors as they come up, and there's a lot of code that it produces, and I would argue tough. You should actually be dealing with the errors as and when they appear. So Go's error handling, errors of values, they get returned as values, and idiomatically they come back as the last value in a set. So if we were to do something like here we go, OS read file. So we're going to give it a name. Doesn't really matter what file we're going to read. It's going to blow up anyway. And returns two things. Now, my linter is already complaining at me because I've called something and I have an unhandled error. In fact, I'm not doing anything with the results from this, so I've got a warning. And to me, this is effectively a compile error, and with my build system, this is a compile error. So I want to be doing something. That's give me a byte stream. I'm going to call that B. Idiomatically in Go, we use short variable names. I'm on the fence about that. If it's very, very close in scope, then yes. Otherwise, use descriptive variable names, but not Java variable names. So maybe use a word that is descriptive, but not necessarily a full sentence. We're only going to be a few lines long here, so B is fine. Idiomatically, like that. So my compiler is a warning because I've got two unused variables. Now, in this particular case, I know that B is not going to get used, so I can tell the compiler I don't care. I'm throwing the value of that away. An error now, I need to check if that's happened. So the standard way of doing that is if error not equal to nil, and we can handle our error and do something sensible. This is not exception handling. These are not exceptions. An error has happened, not an exceptional circumstance. And you can do what you want with your error. And in fact, the error handling within Go allows you, and has been extended to, decorate those errors and almost treat them like exceptions in terms of they can have a type. And you can interrogate that particular type and say, does this error look like this type of error, and if so, I can handle it. And you can also wrap errors. So we have a special verb in the format, so format.errorf, and we can say, oops, I was going to whinge, couldn't read the file, %w, and that's going to generate a new error. Just leave now. That's going to generate a new error that has been decorated. So the idea being that if you can't actually handle the error at the particular point, decorate it with what went wrong and pass it up to something that can handle it. It does mean that you get a lot of if equals not equal to nil in your code, and there are some patterns I used to help mitigate that. Go2 was going to have different error handling semantics, but ironically enough, I think Go2 now considered harmful. Quite literally, they think they've stopped work on it based on the fact that if anyone who uses Python was there for the migration from Python 2 to Python 3, which was beyond painful. I think they've decided that stick with the language that works and keep this backward compatibility promise. And now that we have generics in the language that absolutely did not need generics, most of the pain points have been addressed. The error handling is the one last sort of pain point. And honestly, I can't see how you address it without having an exception mechanism which can be abused, or using this, which can be abused. And a lot of the arguments I hear about both types of error handling are not actually language problems, they're process problems. And why are you letting this code that is abusing the error handling actually make it through your code review process and into production? So you'll find out that I'm also a very opinionated programmer. Many years of doing stuff. I like to make my life simple. So we've had a look at the basics, and we can do some fun things. So Go is this very strongly typed language. Everything has to have a type, and one of the types that never really gets used is the built-in array type. So we can define an array by doing this as an array of 4 ints, and we can 1, 2, 3, 4. So this is an array. It's a size 4. It will always be size 4. It can never be any other size. I could do this and tell the compiler that I'm lazy. Please count the number of elements in this array and make it that size. But this is quite restrictive. We probably don't know how much stuff needs to go into our array, so typically we use slices. So a slice looks like this, and this is actually a data structure that has a size, a capacity, and a pointer to an array in the background. Go has pointers. They're not scary in Go. You can't do pointer arithmetic. I view this to be a good thing. So a slice, treat it like an array. For all intents and purposes, it is an array, but it is an array of typed things. Now, what I can do is I can turn around and say that I've got, let's get rid of this, I've got an int, and it is 0. And I've got, and I'm going to have to use a different syntax here. It's the full longhand way of doing things. It's for you who half expecting him to pull out the car phone thing, shunk. So we're going to have a var_f, and we're going to have this as a float 64. Go does support float 32s. I have never had cause to use a float 32. All the applications I use, memory is not critical or that critical, and I don't see why I should trade off possible loss of accuracy. I've never been working with sort of a constrained enough data set So I always use float 64. And I can turn around and I can say that I want another variable for I2, rubbish naming today, is an int. And in fact, I can use one of those shorthands where I turn around and just make that and put that in there. It's just, you can do the same with const, you can just put it in a declaration block. And I can turn around and say that, actually I don't even need I2, what am I talking about? F is equal to int I. Let's get rid of that. What are you whinging about there? Learn how to program. So I can cast my int to a float type, and then I can print. Let's do a print f, because then we can do a percent. Was it 2t? What's f? F. So that's going to print out my my floating point number. So I've done some casting. That's good. The compiler is able to do that kind of thing. But what I can't do, I can't go off and say that I've got a slice of int, 1, 2, 3, and then my varf, which is a slice of float, 64. I cannot turn around and say that f equals slice of float, 64i. That just, it's not allowed. You can't cast slices. So what you may have to do, if you absolutely positively have to do that kind of cast, is a little bit of longhand where you can turn around and say and this gets me every single time, you can range across a slice. So we can say index is equal to range over the slice of I. And that range can return one or two values. And the first value is the index that it's returning. The second value is the value. And the number of times that I have forgotten that, done this form of the for loop, and then can't work out why I have access to none of the methods on my types. Why is it not letting me do this? Why is the compiler complaining about stuff being the wrong type? And then you go, it's because I'm getting an int back because I have the index, not the type. Years and I still get this wrong. One of the other things I get wrong quite a lot, you'll notice with Go that actually your type definition goes on the right-hand side, and most other languages have it on the left-hand side, and you will still see me put it on the left-hand side some years later. But anyway, we can range through, and in fact we can take the value as well. Let's do this. Let's take the value as well. And then we can say that f I is equal to value, sort of. Still can't do this just yet. First of all, we need to float 64 that. This will... index. This will not work just yet because actually this is an empty slice, so it has 0 values, and although slices will grow, you need to use the append keyword. So this actually needs to be a pre-initialized slice, so I can use the make keyword and I can do len I. So this is a cast of a slice of ints to a slice of floats, which is potentially slow. If you've got a big slice, it is potentially slow and potentially quite memory intensive. So we want to try and avoid doing that. And one of the ways that the Go does this, and one of the kind of reasons why we would sneer again, we don't need generics, is that Go's interface system is incredibly powerful. And the fact that it handles functions as first-class citizens, first-order variable types, makes it nice and powerful. So we often don't care about what type of thing is in our slice for things like sorting, for example. So we can't have you can't pass in a sort of a slice of the any type to order it, because I then can't cast it to the right thing. But what I can do is I can take the, let's get my thing there. I can do, that's a sort package, sort dot, and then, now you'll notice all my function names here are, all my function names are uppercase, the camel case starting with uppercase. This is because the scoping system in Go is based on the first letter of the name. If it's uppercase, it's public. If it is lowercase, it is package scope. Because I'm going off into a different package, which I've just imported with the import keyword, I can only see the uppercase things. Now, I'm a huge believer in making sure your code is semantic. So most people who are using packages that you write will be using them with the package name in front of them, and that adds some semantic context to things. So this kind of tautology with the sort.sort is a little bit, now, willing to cut them some slack here, because when you find yourself jumping through linguistic hoops in order to make it sort of maybe grammatically slightly better, you can make life worse for yourself. But I don't know, I might have called this by function or something, because this does take a function. Is it this one? Let's just make sure it is this one. No, it's not sort.sort. Find the correct one. Although my point still holds with that. This one, sort slice. So we pass in anything, and we also give it a function. So we're sorting, and we're sorting a slice, and we can pass in a function which is an anonymous function. So functions being first-class types, we can pass them around as parameters, and I can define my own sort algorithm here. So I can do whichever way I want to do this. I'm actually going to change my slice just to make this more interesting. There we go. There we go. So this function needs to effectively define less. So how do we define less on a particular thing? So I'm going to do non-defensive code because I can see the slice that's been passed in, and we're just going to return the index of slice that is I, its 0th index, because that is a string, which is basically a byte slice underneath, is less than the slice at index j, its 0th index. So the compiler is smart enough to realize that actually a string is a slice of bytes, so I can cast it here to a slice of bytes. And off we go, and oops. So this is going to be an in-place sort, so I don't need to return anything, and that's interesting. Oh, I know why. Let's do this. It's because it's OTT that I've sorted on. So there we go. I've sorted on the second character because this is a sort algorithm that you're definitely going to need in your career. So we've effectively abstracted away the need to deal with knowing what the slice is, and there's another way that we can deal with this as well. If we have our own custom types, let's introduce types. We have the type keyword, and we're going to call this sortable, and this is going to be a struct. If you are familiar with C at all, this is going to look very familiar. Go is heavily influenced by C. This is the unincremented version of C. So with a struct, you can have various things. So we're going to give it a we're going to give it a name. We're going to give that a string. Okay, so there is my my type. Incidentally, if anyone has any questions during this, do feel free to just shout out. I am interrupt driven. It's not a problem. So if you're like, what's he doing? Do shout. So we've got our sortable thing, and I can hang functions off a type. So I can then call those functions on that type, which is quite nifty. So I can define a func. So we did this as sortable. Idiomatically, this name here, which is this variable name, is the lowercase of this, the first letter of this one. And all we're saying is this function exists on the sortable type. And it's less, and that's going to take I and j, excuse me, that are integers, and returnable. And you may notice that this looks very similar to this. And actually, we're going to re-implement this, reuse this algorithm. Except this is now going to be s.name. And s.name is that. This is why. My type is a slice of structs. So I can then put back my I and j in the correct place. I do things like this with students, mainly because students at university seem to believe that when they graduate, they are going to become quote-unquote programmers. And this allows them to sit in front of a computer and write perfect code all day, every day. And then they see me getting it wrong, looking things up on Stack Overflow, Googling stuff, wondering why it won't compile, screaming at stuff, swearing at stuff. And they realize that actually, when they become a programmer, it's going to be identical to what they are now with maybe just a little bit more knowledge. The only difference between me and anyone else in this room is that I may be 1 or 2 pages ahead in the book. And I haven't read all the books that you have. So we've got our last function here. So the indexes have moved around a bit. This type is a slice of structs, and the structs themselves have a name. So I am grabbing the element of the struct, and then the index in the name. I also need to define a len sortable len, and that returns an int. So we just return len s. And swap. Sortable swap I j int, and that returns nothing. No, don't panic, never panic. And so we can just say si. Because you can do single line assignments, it allows you to do this without worrying about a temporary variable. So we're just swapping things around. Now, if I have done that correctly, I should now be able to say that my slice is a sortable. And this is where the braces start getting fun. Technically, I then put a, well, actually, let's do, just to make it more readable. Define 2 types. So this just allows me to instantiate what's going into the sortable slightly more easily. And then my sortable is now a slice of names. So we're building a slightly more complex thing up here. So my slice of sortable, technically, you might argue that I need to put my type this as a name thing and instantiate it, and the name's going to be 1. That's a fairly boring slice. Now, is the compiler? Yes, the compiler is intelligent enough. If I put named back in there, it's not going to whinge this time. Sometimes the compiler will whinge and say, actually the linter will whinge and say that you don't actually need to specify the type because it's kind of obvious what's going on there. But in this particular case, it seems to be accepting it either way. And we can have multiple things in there. So we can have a name to just to be utterly random. So if we now, this is where we do sort.sort. I should be able to pass in slice. And the reason that's accepting that is this sort function accepts this interface type. And that interface type says that if you have a len function that returns an int, and a less function that returns a bool and accepts 2 ints, and a swap function that takes 2 ints, then you are an interface type. So Go is duck typed. And my sortable satisfies that. And so the code within sort can just sit there and be happy in the fact that I can call len, I can call less, I can call swap, because I know these things exist on this particular type, and I don't care what the internals look like. And you might want to do this on a slightly more complex type. I mean, I'm basically re-implementing what happens in the implementation we had before, because I'm passing in a slice. But if you had a more complex data structure that was sortable but did not look like something that Go thought was sortable, you can implement this this interface, and off you go. So the argument was that Go doesn't need generics because we have this wonderful interface system, and you can be happy with that. Great. But it's not as easy as that. It's wonderful if everything conforms to an interface, but if you're just passing around data types, if you're just passing around primitive types, then you don't have the ability to say, well, you do have the ability to say the match interface, but it is the any interface. So you have access to 0 functions, and now you're going into reflections to work out what it is, and my God, does that make life fun. So eventually they capitulated and said, okay, we'll add generics. It was going to be part of Go too, but they worked out a way of doing it such that it was backward compatible within the language. So if we take a very, very simple example, if I have a type summable, and I turn around and say that this is a slice of int, and I have a func sum on there. Oops, on my summable, yes. Now I can solve this particular well, I can't solve this particular problem with interfaces. It looks like I can. So what I can do here is first of all, let's just do var some int, and we don't want the index, but we do want the value range over the slice of ints, and then we can do sum plus equals v, and then we can return sum. Okay. So I can now make a summable type. Okay, that's why. I always get worried when my linter wants, but because it wants me to define things differently if it's empty. It's not going to be empty for long. 2, 3, so I believe that is around. I believe that is going to total to 6. You'll notice I stopped early on because I did A-level maths, and therefore I'm entirely calculator dependent. Do that, s dot sum, great. Run this. We can count to 6. You might say, okay, well, we don't need generics because we can have an interface. In fact, we can turn around and say that a summable is itself. Let's define our own interface. It's going to have this sum function in it. So anything that defines this sum function is now a summable type. So we're going to have a type of, we're just going to call it ints. It's going to be a slice of int, and we're going to call that ints, and we're going to call that I. Blah, 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 and then this is going to be a slice of ints. This is still going to work. Still 6. Great. Now I can have my function, one of my favorite function names, do stuff. It's descriptive. We're going to take our summable and we are going to return. Yes? If sum is 0, if your slice of ints is 0, nothing will happen with this, and we know that this is going to be 0 because Go has a well-defined 0 value for everything. So the 0 value for almost all primitives is 0, apart from string, which is the empty string, the empty slice for all the slices, pointer, interface, map is nil. There's one other that's not, bool, which is false. But they are all well defined. You're not going to get garbage in your, with any pointer or anything like that. You're either going to get nil. We don't have null, we have nil. That's how you avoid a null pointer exception. You just call it something else. So yeah, I know that sum is going to be 0 here. Spot the C and C++ programmers. I don't have to care about stuff like that. Next question.
Next line is, I missed this. What is this? Why is this underline, comma, v?
Okay, so range can return 2 values. The first value is the index. I don't want the index, but the compiler will not compile if I don't use a variable. So what I'm saying there is I know a variable comes out at that point, but I don't want it. So underscore, I basically think of it as the bin. So it's one of those things where I cannot think of a situation where you would define a variable and not use it unless you'd made a mistake. So the compiler is just protecting you from yourself there. And trust me, I've seen my code. I need all the protection I can get.
Is that like a scratch code?
Pretty much, yeah. I mean, it literally just gets thrown away. So it just says, I know something's coming out there, and I'm dealing with it. If we get time, I'll show you what I do with some things on Panic, which looks at first glance to be a little bit, why would you do that as longhand? But actually, it's an expressive way of saying something. So we've got our do stuff. It's taking a summable, and I can now do things with my summable, and I want to return a float 64. No, float 46. It's inventing types now. I want to return a float 64, but my summable only returns ints. So now I've got to mess around. Also, if I wanted to have a type float, which is going to be a float 64, and then I'm going to define my let's define this on the floats type. Has to return an int because it's got to match that particular interface. So, well, this is going to end badly because this is going to be casting that to it. So I'm losing all kinds of precision here. This is not going to work. So I'm either going to have some method of passing in a pointer to the type that I want, or there are ways around this, but they all smell. When you start looking at things like the regular expression package, where you realize, well, in fact, we can look at the regular expression package. You've got must compile. That will compile, doesn't matter. RE dot. So we've got find all string, find all index, find all string index, find all string submatch, find all string submatch index. This came from the best of intentions. But the road to hell is paved with good intentions. So you find these little snippets, including the absolute worst, just a complete aside, but US. Just find the correct comment. Time uses a format string, and that format string is 1, 2, 3, 4, 5, 6, 7. If you know what Mountain Standard Time is, and use US timestamps. I can't find the particular thing now, but the documentation has been updated to say that it is an unfortunate historical anachronism that this happened, and there is a reason why I have a package which is called GOATS, which is Go Alternative Time Strings, which allows you to use sensible time strings rather than mainly because I had users that were providing me with time formatting things, and I could not, hand on heart, could not go to them and go, it looks like this. Just give them the SQL time format strings, and they were happy. So there are ways that we can get around this issue, but they all smell. If only we had generics. Well, it turns out we do now. So what we can turn around is that we can say that this is typed, and we can say that it is typed on a type T, and is there a countable? Numeric, that's the one, number. The thing's called now. Let's just define some things. Int. No, once been doing this in interface. Right, okay, so we need to use our special interface keyword that they have given us, where we can turn around and actually define a bunch of stuff that we accept. We're going to say we're going to take an int in 64, 64, I'll do. I'm going to say that this is a countable. So this is now typed, and we have access to type T. So we can turn around and say that T returns, sum returns this type T. So now we can turn around and say that our ints are in fact, this is not a comma, this is an OR. Learn how to program. So this is ints are countable, summable, and it's going to be of type int, and our floats are summable and of type float 64. And these now become I think, do I need to actually do that? Yes, I do. Type T. Aren't generics fun? Having to get the T's in the right place, and this is a problem I have with Java generics as well. Everyone turns around and says generics are a wonderful idea, and then it comes to actually using them, and you realize that maybe not. So ints is typed on No, that is not right at all. And there's a reason why I didn't script this particular bit, is because this is what I wanted to show. Generics are a pain in the backside. No, that is definitely going to be an int, and that is definitely going to be a float 64. Vi is of can I do that? Do that. And what we're doing here is we are failing to solve a very trivial problem with our new hammer. Dun, 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 dun. Right, I think we can now turn around and say that this is I know what I've done. This interface is not needed anymore. Struct on type T countable. That's going to have a value of type T. Actually, no, I don't need to do that. We can just do it's a slice of type T. Make it even easier for ourselves. Slice of T. Great. They go. Don't need them anymore. This now lives on summable. And is a sum, and that's going to return your type T. This now wants to be a type T. This is going to be a range over S, lowercase s. Now, because I have limited my type to things that implement the addition operator, I can quite happily do this, and I can return this. So this now goes away. That's the one. Which time do I have? Enough time. So this can now be a summable like that. Does this want me to specify it? Yes, okay. Of type int. There we go. Sometimes it lets you get away with, not in this particular case, sometimes the compiler is smart enough to work out what the generic type is. And now I can do stuff, and I can make this function generic as well, countable. And this is going to have a symbol of type T, and we're going to return type T. So I can return symbol.sum. That's all going to work, and now we can just do stuff on S. This is where the compiler is clever enough to work out that I don't need to turn around and say that this is on an int. It's clever enough to work out that this is now cast on an int. So I can now create slices of any particular type, as long as it lives in this thing, and I can do some interesting things. This is one of my fun ones, because string understands what plus equals is. It's just string concatenation. I can actually throw that into my set of accepted types. So this will all go off, and hopefully, yes, it will run, and I can change this now to be float 64 and pop ourselves another little number in there. We're not losing our accuracy much. I love floating point numbers. So our generics have now come to our rescue and are going to save the world. Once you've worked out how to reason about them and remember what the syntax is and where the square brackets go, and so great, all is solved, except you then tie yourself into knots. So I have a configuration package. I like to be able to configure things from the command line, from environment variables, or from a config file. Typically, I would have a JSON config file, which means that I'm accepting a source that takes only strings, a source that takes only strings, and a source that actually maps very well into Go, as a struct of any type, and within that you can have a struct of any, a slice of any, an int64, a float64, a string, nil, Boolean value. So already we're dealing with lots of different types there. And then I don't want the values that I'm pulling in to be stringly typed. I want them to be strongly typed. So if I'm getting stuff from the environment, if I'm getting stuff from the command line, I want these things to be of the type that I'm going to use. So if I'm getting an int in, I want it to be an int. Now, that's not a problem with the JSON stuff. I can just give it to the JSON parser and my ints drop out. But if I'm getting something from the command line, we've got some hoops to jump through. Now, the standard way of doing this is with the flags package. And we can go off and so flag. Idiomatically, you don't have the S on a package name unless that is going to collide with a keyword. So you'll notice it's strings because string is already a keyword, but it's flag. And with the flag package, we can turn around and say that I want to take an int, and it's going to be called count, and I think the next one's a default value. Yes, default value, and then the usage thing. So our default value is going to be 42, and the number times to do things. And this is going to go off and return me a pointer to an integer. We've not really covered pointers. And I can do flag parse. And that will go off, and this pointer to an integer is going to be initialized with whatever came through, 42 or a value. If it's not an integer type, the flags package will handle whinging about usage and everything. But now if I want to use that, I can't do I++ because that's a pointer. I have to dereference it and then do ++ on it, which is annoying. Don't like doing that. So typically what I would do is I would define my I up front. I would do the int var, and I would pass in a pointer to my values so that I can now just fiddle around with my my value. My package works in a similar way. You sit there and you pass in pointers to things and define various stuff on it. More things to define, but I can't help looking at this and going, there's some generics here. I could just turn around and go, it's a value that I'm taking from config. So I should be able to do something like I'm going to call it flag for now, and that can be typed on type interface. Options for now. I'm going to accept balls, and I'm going to accept ints, and I'm going to accept float64s, and I'm going to accept time.durations because I'm nice like that. I'm going to accept strings. What else might I want? I think that's it for now. So I can now type that on options, and I'm going to take a pointer to type T, and pointer to type T, we'll call that. And then I'm going to take just a default value of T and a description string. And I should be able to do something with that. I need to do a flags read effect, okay. I should be able to do something with that. And in fact, I started doing something with this. It was great. It was working really well because previously I had to mess around with generics and work out, did I have a pointer? Did I have a non-pointer? Were they both pointing to the same time? Now the compiler's guaranteeing this to me. I know I've got a pointer. I know I've got the type that I can do all kinds of interesting things. Hurrah! So this code worked well. I was pleased. But your configuration is done by more than one thing. You've got more than one flag, typically. So we want a collection of config items. So if we turn around and say that actually this is an interface, that, and we will have this as register. Didn't want that at all. There we go, so that's my interface. And now I can have another type, which is going to be config items. And this is going to be a struct, and that is going to take a map of, do a map of string, because we can use the sort of the name that we've given it on the command line or what have you. And then we're going to take our config item as our values. This is just basically a dictionary type thing. So this is going to be our config. Hurrah! Except the config items, config item, that's why it's not complaining. Config item is not going to compile here. I need to tell it what type it is. But can it be options? Type, no, it can't be. I've got to give it a concrete type in there. So, that works. So as long as my program only accepts flags that provide integers, I'm absolutely fine. Otherwise, I guess I could have int config and string config. But again, we seem to be descending into the pre-generics world of pain. This is, I think, the fourth time that I have got very excited that generics is going to solve the problem that I have. And my code is going to be wonderful and readable, and I have come out of it with some generics. I think there's a little bit of generics in the rewrite I've done. And then I've gone back to reflections, because it turns out that some of these problems are actually quite hard to solve. So while it is entirely possible to define a class of problem in the scope of generics, and it is very useful to have generics in the language, it's not actually that kind of silver bullet that some people think it's going to be. Now, I know some languages have different generic implementations that may be much more powerful than Go's, and you may be able to do this kind of thing, and great for them. But if you're coming from a language like that and going, oh, I can do the same thing in Go, yes, you can, but it's called the reflect package, and your code is going to look hideous. I know, because I've written a lot of stuff like that, and I hide it away in my config packages and never think of it again. I'm very pleased they added generics. I'm very pleased that they were able to realize that they had made a mistake by not adding it into the language. But I do think that it does need to cover that caveat emptor and buyer beware. And if you do break it, you get to keep both halves of the binary that you've broken. Now, this has been a whistle-stop tour of Go. So there's all kinds of stuff that I have not covered. Normally, I would do my Go training courses over 3 days. And an awful lot of slides and an awful lot of jumping into the IDE. So doing the language any kind of justice in 90 minutes is not possible. But hopefully that's given you a flavour for what they've added, given you a flavour for what Go does. I love it as a language, but that's because I exist in a world where it works well. And I've had some very interesting discussions with people who have heard that Go is fast. It is fast. And then start talking about we needed to do this kind of performance. And you need to explain to them that actually, no, if you need real speed, then please go use Rust or C or Assembler. And then you find out whether or not they actually require that kind of speed. I've not covered Go routines and channels, which is a very, very easy way of sharing data in highly concurrent systems without sharing your memory access and without dealing with the concurrency issues that most languages come with. And again, I've had arguments with people who have said that they require this speed. It was a financial application, but were insisting that everything had to be done through Go routines and channels. Now, I applaud that because it makes your code easier to read, but actually it is slower than using mutexes if you know what you're doing with mutexes. So if you really do need that kind of speed, then actually you need the core of your program to be some horrible thing written in a language that is optimized for absolute speed, or the speed requirement is not actually a real thing and you can go make it look nice and be understandable. And it's one of the things that once you get how channels and things like that work, they can be very powerful. And in fact, channels with generics is very nice because you can start passing messages around. And I've started writing a library that effectively is a publish and subscribe message broker type thing. And you can just turn around and say, right, I want one of these things and I want it to handle types of this type. And this is where generics shines, because I'm not actually fussed about what the type is on the pipeline. All I care about is making sure that all the subscribers are getting it and everything has been orchestrated properly. But you care about, when you come to consume that it is of this type, not that I am getting type any and I now need to cast it in the hope that you have given me the correct type and I'm not going to fall over in a crumpled heap on the floor. So if you're interested in all of that kind of thing, there are many good talks out there on how Go handles its concurrency and some of the fun stuff you can do. I quite often like throwing up a million Go routines on this laptop and just, it works. As long as you're not doing anything too bonkers in those Go routines. Obviously there are hardware constraints, but you wouldn't dream of other languages, Java, I'm looking at you, of throwing up a million threads. It tends to be more a systems language. So if you're doing a lot of front-endy stuff, it might not be the right language for you. You can write web servers in Go, and I do, but depending on what your use case is, there may be better languages out there. You may need other languages for more expressiveness. You may need other languages for things like, dare I say, AI and machine learning and stuff like that. So it's just one of the things that you can add to your tool set. But I would recommend that you look at it, have a play around with it, add it to your tool belt, and it's useful, it's there. If anyone's got any questions, I've got 5 minutes left, so feel free to ask, or grab me when you are around. And if you're interested, I'm doing a talk on the process flow that I go through when writing code on Saturday. At some point, the schedule's been updated. So it just seems to say thank you very much for attending, and I hope you've had fun. So the question there is what is Go good for? And the answer to that tends to be things like DevOps. So a lot of things that come from HashiCorp, for example, are written in Go, and you can do stuff with that. It's wonderful if you're doing Docker deployments. Didn't manage to look at that, but because Go is a statically compiled binary, you can use the scratch Docker image, which is the empty Docker image. So you just basically, most of my Docker images have a certificates directory, because there is nothing in this thing, and the Go binary. My older ones have any files that they were referencing. Go has subsequently added the ability to embed that into the binary, so now it is just the binary, and it makes deployment really simple. If you want something that is going to be used by lots of new people coming into the company, for example, so if you've got a large expansion phase going on, it can be nice and easy to learn on what's going on there. And it is, like I say, it's one of these things that is nice and easy to understand. So if you've got systems that do require maintenance at stupid o'clock in the morning, I would much rather be dealing with 10 lines of Go that are expressive rather than one line of Scala and going, well, I know it's broken, but how? So that's where I say it comes in. It's a fast language. It is generally fast enough, but if you need raw speed, there are other languages. If you need artistic expression, it is not the language for you because the compiler is so bad and the linter config I have is just insane. If you've got a lot of front-endy stuff going on, it may not be the language for you. You may want to use Node because then you're not bouncing between two languages. If you need something that isn't type safe, because sometimes it's actually a pain in the backside when you're processing data to have this type safety, then again, you may want a different language. So the question is, what happens with things like sort functions and what have you? What happens if you pass in a type that doesn't implement the interface within sortable? Or even actually, if I was to try and create something that was not a, it's in 32, for example here, it becomes a compile error. So in this particular case, in32 is not an allowable type within my options. If you were to pass something that did not implement all the methods of the interface on sort, then the compiler will just turn around and go, this is not the correct type. And it will actually tell you that it's missing these particular methods. One other thing I will quickly point out before I let you go, Go is a modern language and is designed to be used in a modern development environment, and there are a lot of tools and a lot of things that help you. So whereas in the olden days, yes, perhaps developers may have done nasty things and done bad practices, it is so easy to set up your system so it warns you about stuff in your IDE, in your editors, in your build pipeline, during code review. There's just no excuse for some of these, we do this to make it absolutely bulletproof. Your process needs to involve the code and everything surrounding it. So I go into that a lot on my talk on Saturday. So I normally have arguments for most of Go shortcomings, and if I don't have an argument to support it, I'm like, absolutely use a different language. Cool, thank you very much.